Hello, everyone. We're live. We're just talking about lowering the chairs so we could look in all your beautiful faces. So, hello, everyone. Welcome to our almost weekly live stream. Next week, we're not going to have a live stream. We have a live stream this week. We have the next live stream in 2 weeks because next week it's the 1st of May. And today my name is Tony, and today I'm joined by Christian and Edgars. Thanks guys for taking the time. Thank you for cooking, everyday cooking, right, in the lab, in the kitchen. Christian is our head of developer experience at newly branded GenLayer Labs, and Edgars is our CPO and co-founder at GenLayer Labs.
Good to see you.
Hi guys. And some of you have seen myself already. I'm Tony, head of content and community for GenLayer. I'm around in all the Discords and Telegrams and live streams of GenLayer. So thank you for taking the time, all of you who are listening. We're getting a few more participants in. As always, we're going to have a POAP at the end of the session. We decided to move to first come, first serve POAPs for the live stream sessions. So we will share those in half an hour. For now, please download the POAP home app, and we will share a secret passkey with which you can then mint the POAP at the end of the session. Okay, today we are talking about how GenLayer works. And because I am not the right person to explain everything, under the hood, how it works, how this engine keeps on running, I have with me those two who can explain it very well. For those of you who have seen, we've also released a product blog post where you can also dive deeper, but we will also go into some of those things today. Before we start and before I give the floor to you guys, I would just like to repeat what we were building here. GenLayer's trust infrastructure for the AI age. We are an AI-powered distributed ledger and digital decision maker. And how this works is we are integrating LLMs at the consensus layer of our blockchain. We are enabling intelligent contracts, and compared to classic smart contracts, intelligent contracts can read data, fetch any data from the internet, real-time, reliable data, engage in complex decision-making, and interpret natural language. That's the base level overview. And now if we talk about intelligent contracts and everything they can do, maybe let's start, Edgars, with what do you envision intelligent contracts to be capable of? I mean, that's the core tech of dApps. What can you build with intelligent contracts, infusing them in dApps?
Thanks, Tony. I think that's a great starting point. And to kind of set this up, we've been building this, for more than a year now, working on it for quite a while. But we wanted to give this kind of general overview, entry point for everybody new that's joining our community to understand how all the pieces fit together. And then keep you along for the journey with these monthly product updates that we put out the first one off. So Tony is absolutely right. Intelligent contracts are the core part of it. Everything around it is just a way to make these contracts work, how we enable this, but the core is the contract itself. So that's what we want people to do. So the goal of an intelligent contract is to kind of combine the best of both worlds from a traditional paper contract. I want to hire you to work for me. I want to hire somebody to write a blog post. I want to, make a bet, about some outcome in the world, or some trading contract, set up an organization. All these kind of things we could do with paper contracts and have been able to do for, centuries, if not millennia, depending on what you count as the kind of starting point.
Yeah.
Which is, of course, a super powerful system. It really enables people to work together with each other much better than, if I have to have my own army, you have to have your own army, we can't trust each other, we have to go fight. Instead, we can submit voluntarily to the jurisdiction of some judge, some arbitrator, whatever the system has been in various points in time. that's going to resolve our dispute for us. We're both going to accept the outcome. Sometimes it goes against me, but the fact we can work so much more easily that we can have this piece of paper we sign, we're good to go. We can kind of trust each other and work together much more easily. The problem with this traditional system is that it's really slow and really expensive. If you ever had to deal with any sort of contract dispute, that going to a judge, it's going to take you a few years and hundreds of thousands of dollars in the United States.
Oh yeah.
Even for a small case, that is, in different places the cost is different, but the general point basically stands, and the legal system gets backed up. Some cases take like many, many years to resolve, by which point it's not even, your counterparty is long bankrupted or dead, and so the point is not you cannot recover anything in the end, or it's just a huge waste of time, of time and money. And for many cases, if I'm hiring somebody for $1,000, it's not even going to make sense for me to pick up my phone, to call my lawyer. It's going to cost me more than the dispute is worth, so I kind of just have to let it slide. So slow, expensive, inaccessible, really powerful, really enabling evolution in how humans are able to work together with each other, but with limitations. Then along came smart contracts, originally proposed in the 90s. Then Vitalik with Ethereum kind of made them come to life in 2014, and which solved many of these problems, right? They resolve instantly, minutes, not years. They cost, again, cents, or if it's really expensive, a few dollars, not thousands or hundreds of thousands of dollars. They can move assets around, so they can actually hold assets, and they are self-enforcing. So if we have a bet, and there's some money in the escrow, then, in a traditional paper contract, either we have to have some third party to hold the money or get the police to then try and enforce it. Whereas the smart contract itself can move the assets around. So instant enforcement, self-enforcing, really fast, really cheap. The problem is they have all these nice properties, but they're actually quite limited, which is why, if you think about it, most kind of contracts that you have on paper, you cannot actually put in a traditional smart contract. I mentioned this example. I want to hire Tony to write me a blog post. He's a great writer. I'm going to pay him $10,000 for this blog post. Well, we could have a paper contract about this, right? If there's a dispute, really problematic to get it actually resolved if he doesn't deliver, or if I don't pay him, it could go either way. For each of us to resolve it, it's hugely expensive, hugely slow. We could try to do this with a smart contract, but if you try to do it, depending on how much you've actually dealt directly with smart contracts, you're probably aware that you cannot actually do this without some other human in the loop, because the smart contract, it's disconnected from the outside world. So unless there exists some custom oracle that can detect that the blog post has been posted, the smart contract cannot deal with that. It has to be deterministic. It has to be isolated. That's why you have oracles, or you have human-based oracles. So you have something like UMA or Claris, which is basically a group of people, a DAO, voting. They all look at the blog post and they decide if it's good enough or not good enough. And the second part of that, I was kind of already alluding to this, which is that how do you know what is a good blog post or a bad blog post? You can't. This is not something that you can actually describe in low-level computer code in Solidity or any other traditional smart contract programming language. These kind of languages deal with numbers and multiples, and if this, then that, this kind of logic. But is a blog post good enough or not good enough, according to some set of natural language criteria, is not something you can describe in this low-level formal language. You actually need the power and the subjectivity, but in a good way, of natural language, where you can have these criteria that are quite flexible. Is this blog post interesting? Is it written in good English? What is good English? But if you ask something like this to a human, they can make a judgment, right? A human judge can make this sort of a judgment if you defined it precisely enough. Similarly, we're seeing now that with large language models, they're also able to make these kind of judgments. You can ask ChatGPT, hey, here's this blog post. It had to have 7 paragraphs, covered this and that topic, written in good English. All these kind of criteria, not be a copy paste of any other blog post in the system, anything like that. And ChatGPT will do a pretty good job evaluating this. The problem is ChatGPT is kind of run by OpenAI. Somebody has to execute it. So is it going to be me or Tony executing it if we want to use it as a judge? It doesn't work. So the extra component that intelligent contracts bring you is that you can use this AI, large language model based judgment, with access to the outside world so that they can see the blog post, they can then evaluate the blog post, and they get all these properties of a traditional smart contract, such that this contract can hold assets and it can move around these assets based on, let's say, these large language model decisions. So what you get is this AI-based legal system with intelligent contracts instead of paper contracts or smart contracts, and this network of AI-based judges that can, in minutes, for a few dollars, make resolutions on these kind of contracts, so that you can have all these performance-based contracts. You can do things like prediction markets, right? Right now, all prediction markets are resolved by people. So say there's a market on who's going to be the next pope. If you're a Catholic, you're not supposed to bet on that, but it's a huge market. So what happens is, when the next pope is announced, somebody needs to go into the system and actually, click, kind of say which answer is the right one. Some systems is just some person in the company. It's not super reliable. What if the company decides they want to screw everybody over? Then there are decentralized prediction markets, like Polymarket is the biggest one. And here you have these human-based systems that I mentioned, like UMA, in the case of Polymarket, where it's people voting on the outcome. But if you've seen that also, first of all, it's very slow and it's very expensive, just because humans are slow and expensive compared to AI. Also not super reliable. Humans can collude. Humans can try to bias the market, or it's not ideal. So on GenLayer, you can have an intelligent contract that's going to be resolved by AI. That's going to go out to a website or a number of websites, multiple sources, and then resolve this market and decide which side should be paid in this prediction market. You can do organizations such as AI-based DAOs that are automatically ingesting proposals from the community, issuing bounties, issuing grants, a ton of different stuff. You can bring many things that right now need a paper contract or some other human-based system, make it orders of magnitude faster and cheaper.
Okay, I would just like question clarification. I think you can add on that, Edgar's, because we have a few questions, and I see Vatan's question, which is a really good one regarding the equivalence principle. We have some based on scalability and ZK Sync. So we'll get to that in a minute. What I was just referring to is what you said before, Edgar's, is you have this, like what is a good article? What is the most beautiful painting in the world? What is, a well-built whatever road? What is a well-built piece of software? I think it's important to understand, as you can specify the prompt as if you would be prompting ChatGPT to tell it, follow these requirements, do this, do that. The developer, and that I think that's the important part here, is that the developer sets those requirements, right? And that brings us directly into the middle of optimistic democracy and equivalence principle, which is also one question. That's why I thought it's very good to combine these two. So if you could maybe start with, how does that work? How does the developer set that? And then we can move over to optimistic democracy.
Yeah, Christian, I don't know, maybe you want to take this
Sure,
one.
I can take this one, of course. Yes, of course, the developer, when they work on their intelligent contract, they can do these calls to LLMs, also to get contents of a website. We have managed to find a way to design the way that could make this to run in the most deterministic way, right? Because of course, answers from LLMs are not deterministic. The content that you fetch from a website is not deterministic. So when you develop your intelligent contracts, you have an SDK library that allows you to write this piece of code in a way that they are going to be evaluated in the consensus democracy process to get a deterministic output out of it.
So the developer would determine, okay, let's say this is the article, the best article for me, for this particular developer, would be if it has, at least 1,000 words, if it has, it fulfills the criteria of having strong verbs, of having, paragraphs, lines, whatever. But it is always, so someone has to subjectively decide which the requirements are going to be. Those are the rules laid out, and then the LLM basically decides on what it has to do.
Yes, I think there are kind of like two angles to look at it from, basically. Yeah. So one way, if you're a smart contract developer, or at least a little bit familiar with how that works, then you can, for you, the easiest way to think of it, a practical way to think of it is like looks the same like a normal smart contract in Python, but the structure is similar to Solidity, except you get these extra instructions, which is access any website or API to fetch the data. This is not something you can do in Solidity. And then you can also execute a natural language prompt. And what does that mean exactly? Is whatever you describe in natural language, imagine, if you could think of it as a human. In fact, the way you should write these contracts is thinking of, if you had a judge basically able to resolve any type of contract, really smart, really fast judge that can, be very detailed about how they want to output JSON or anything. It gets a little bit not like a human, but in the sense that you could say, okay, here is the input article that Tony has written.
Mm-hmm.
And here are my criteria. My being, I'm the developer, or I'm let's say the employer of Tony is defining. You can build it in different ways, but basically, here this is what you would put into the text prompt for the judges to resolve. So here's the input article. Here's the criteria for what's going to be a good article. It's going to be at least 7 paragraphs. It's going to be written in quality English. It's going to cover the topics of intelligent contracts and optimistic democracy, and then how they work in a decentralized environment. Probably some other criteria. You want to be, the more precise you are, the more objective it can be, because it's the same way you would think about a paper contract. As if I'm going to take a very simple paper contract where I just say, Tony's going to write a good blog post. Well, then if we go in front of a human judge, it's also not going to be very reliable. How can a judge, it's very subjective. What is a good blog post if you keep it so open? And
have I fulfilled my obligations to the extent that you want me to fulfill my obligation? That's
exactly. You want to be more precise than that. What counts good? You might put some examples or bad examples. If you look at any paper contract, it's usually multiple pages long with a lot of quite specific criteria that's going to define that. And then if you go in front of a human judge, they can actually make a reliable decision. You can expect what they're going to decide because it's very clearly defined. And in the same way, these large language models are starting to be able to make these decisions.
Yeah, I think that's
can add something
basically
to that would be that as a developer also means keeping a lot of details on how the actual consensus works. Your code is going to be executed by one of the nodes of the network, and then other nodes are going to validate or agree or disagree with that execution, right? So you as a developer, you can choose if the outcome of the node that is running the first execution and proposing an execution result, if all the other nodes need to agree exactly to the same outcome, or if they can evaluate that outcome to agree or not, if it's valid with some criteria. So you have that flexibility as a developer, of course, because you are dealing with LLMs, so you need to your code to be adaptable to that.
Yeah, I think this kind of jumps into the question on screen from Vatan, which it kind of gets to that, which is that the intelligent contract, the whole GenLayer system using optimistic democracy, that's what OD stands for in the questions, or consensus mechanism, it doesn't inherently try to get to truth or any such concept like that. It's more flexible than that. You define what is the leader going to do. So how do you first produce the answer? For example, if you're resolving a prediction market, then you would, let's say, go to some websites and fetch the answer. What was the score of the football game? Who won the election? You try to extract that answer from the website. And then you also define how other validators can see if they agree with the leader or not. In the case of fetching an answer, they would have to agree pretty much exactly. So they also go to some websites, maybe different websites. One of them might go to CNN, one might go to BBC. They see if they agree on the answer in the end. Or it can be more subjective than that. It can be that one of the leader is going to produce some summary of an article, of an input article, and then the other validators, instead of producing a different summary and trying to kind of compare two summaries, which wouldn't be it was not how you would approach it if you were doing this with humans. In that case, they would just kind of take the leader's output and evaluate against some criteria in a very similar way that I was talking about. How do you evaluate that Tony's produced a good blog post? So it's very flexible. It's up to you, the developer, to define or the user of some application that's using intelligent contracts to define exactly the kind of criteria that you want to decide. So it's more like a reasoning engine that you can give instructions to. These instructions are a lot more flexible than what you can do with low-level code. It can deal with these more human concepts of quality or well-written or all these kind of things that you cannot really describe with low-level code. But it's up to you. So the system is completely open for you to define what true means in each scenario or how each validator can compare with other validators or things like that. We cannot hear you, Tony. You're Tony, you're muted. You're muted.
Sorry, thank you. So I see all of your questions. Thanks, Edgars. I see all of your questions. It's just I'm trying to kind of attach them to where we want to go within this live stream. So all of the questions will be answered, as we just did with Vatan's. I just would like to keep some sort of logic because, there's questions also coming up about Python contracts. How do we split them up in deterministic, non-deterministic, about scalability, versioning, how do we keep up with compatibility, intelligent contracts, and LLMs. But again, I think before we go there, I would just like to go a step back and kind of try to understand, like we've talked a lot about, intelligent contract, validator picks it up. How can I, as a user, so, there's going to be a wallet that a user is going to be able to use in the future. You send in a transaction. This transaction gets, picked up. By whom who picks it up? Is it being whispered in the network? Who starts to compute first? Like, how does it work until you get to this process of optimistic democracy where multiple LLM-powered validators agree on this subjective truth? Maybe you can walk us through the process there.
Yeah, well, there are different levels of depth we can get into. I'll start with a more high level, and then as needed, we can jump to lower levels. But essentially what happens, the interaction model is quite similar to how you interact with other dApps on other blockchains. You imagine you go to Uniswap, you connect your wallet, you execute the transaction. Similar thing on GenLayer. So you connect your wallet to some application that's built fully or partially on GenLayer, and you send transactions to it through your wallet. So that's all very similar to other blockchains. What's different is, of course, what the transactions can do, what these contracts can do, and how they are processed. So that's unique. We call this optimistic democracy. The idea behind optimistic democracy is that these large language models, although they are computer programs, so they run on your GPU or some cloud GPU for OpenAI or whatever, they actually don't behave quite the same way as a normal computer program does. A normal computer program is, if you press, if you ask what is 2 + 2, it's always 4, right? It's always going to be the same execution result. So a traditional blockchain, a smart contract works the same way. Whatever is defined there is always going to produce exactly the same output. If this, then that, otherwise this, then that, right? This is called determinism. Whereas if you take a large language model, at a very low level, it is deterministic. If you execute it the same way, it's going to produce the same answer. But if you execute the same model multiple times with different initializations, you're going to get different answers. You can see this yourself. If you go to ChatGPT, you ask the same question, you can even regenerate the answer. You're going to get a different answer every time. More than that, if you ask different models, you're also going to get different answers, some correct, some incorrect, sometimes correct, sometimes incorrect, right? As well as some of them are more biased in one way or another, or different personalities, or they don't want to answer certain things. So in that sense, they are much more similar to humans than to a traditional computer program. And what that leads you to is the fact that you don't actually want to trust a single large language model to make a decision. You want many of them, and you want to aggregate their knowledge and have them work together the same way you would design the system with humans. You wouldn't want a legal system where there's one judge that makes every single decision, about everybody, right? What if they had a bad lunch someday and they're in a bad mood, or there's no way to appeal or nothing? That wouldn't be great. There's a reason why we built practically everywhere in the world. We built systems that have some checks and balances and different parties and different levels to appeal, especially legal systems. So we took inspiration from that. And we designed a system that consists of many different validators with many different large language models, which they're free to choose and optimize over time. So the system can get smarter and smarter as this technology gets smarter. And we built a mechanism called optimistic democracy that allows them to act as these checks and balances where, well, let me walk you through the exact steps. It's not really all that complex. So let's say a transaction comes in. First, one validator is selected to be the leader to propose an answer. So they take whatever the task is, whatever is described in the intelligent contract, they execute it and they propose it to all the other validators. At this point, the transaction is not yet accepted, so it's just proposed.
Yeah.
And then in the first round, we get 4 other validators that check what the leader has done. And they check in these different ways that I explained, either by also producing the same result and seeing if they get the same result or a different result, or by evaluating what the leader has produced, or again, it's quite flexible. You can set it up in different ways. But what they check is, do they agree with what the leader has produced, given what the developer has specified as the criteria for agreement. So this is this equivalence principle that's been mentioned a few times today. But the basic is just a definition from the developer. Okay, what does it actually mean for me to agree with the leader? Do I have to get the same answer, similar answer, with some bounds, or do I just evaluate leader's answer and see if I like it or don't like it? Anything like that. So anything goes, but you define how they can actually agree if they produce different results, or disagree if they need to. And if they disagree, so let's say 3 out of the 5 validators in the first round actually say, no, I don't agree with the leader, then what happens is that answer is rejected, that leader is removed, a new validator is added to the set, they select a new leader, and they try again until they can get at least 3 out of 5 validators saying, yeah, I agree with this leader's result. So we all kind of, we have a majority. That's why it's called democracy. So we're trying to get to majority where they agree about this answer. And if that happens, then the answer is provisionally accepted. So it kind of already goes into effect. But this is only 5 validators, right? And we plan to have something like 1,000 validators because we really want a huge diversity of them, aggregate all this intelligence, have them work together to really achieve as much accuracy and quality as possible. So what you can do after this first round, if for some reason you still disagree with the answer, or anybody that disagrees with the answer or thinks it's just not good enough, you can initiate an appeal by submitting a bond. And at that point, we're going to add twice as many validators. They're going to check the current answer, see if they still agree with it or not. And if not, then they can cancel the current answer and start a whole new process with a new leader and these twice as many validators to produce a new answer and hopefully get to acceptance on that. And you can keep escalating these appeals, doubling and doubling the validators at each round until in about 7 rounds, you've reached the entire validator set of 1,000 validators, and then they're all voting. I mean, most of the time you really shouldn't get to this point, but that's how you can ensure the maximum security. You can always escalate it to the biggest, largest validator set, and they will be voting on this answer and produce a really good answer by aggregating the intelligence of all the smartest language models, of all the all the latest and greatest systems that are out there.
And how, on which level, Christian, would that be? Like, why does GenLayer split Python contracts into deterministic and non-deterministic? Can you explain on which level that happens? How does that look in the studio, and what part of the deterministic and non-deterministic goes to the node? What's the difference compared to a classic validator?
Yeah, of course. I mean, it's not like we split the code exactly. I mean, it's the way that you code it on your intelligent contracts, right? So the thing is that in your methods, you can only have deterministic code. For example, if you're doing nothing that calls an LLM or fetches a website content. But if you need to do so, then you have a set of methods and from a library that you can use to insert some block codes, some code blocks to perform these calls. And those blocks are the ones that are going to be evaluated in this way, right, by the leaders and the validators if they agree or not, and to produce between all of them in this consensus mechanism a deterministic output. But it's not like the code is split. This is in the same, let's say, file that you are coding your intelligent contract. you just call these libraries, and you do it in a way that you isolate sort of this part of the code in the same file.
Could I have double, triple, quadruple isolated non-deterministic natural language inputs?
Yes, yeah, of course you can have as many as you want block of the non-deterministic code.
Yeah, the reason you want to have this split, so kind of think of it this way: you want to, some things can be deterministic and they should be, and you want to constrain what the validators can do, because with all this power, at the same time you get some risk, right? In the end, whatever all these validators decide, all 1,000 of them after all the appeals, that's what happens. Let's say, let's keep using this example of this contract about a blog post that I have with Tony. What I want to use the large language models, what I want to use these AI judges for, is to decide whether the blog post meets a certain set of quality criteria or not. But once they make that decision, true or false, is this good or not good, I don't want then to have all this endless flexibility for them to decide, okay, how much of the money to actually send. Or, what if Tony puts some weird instruction in the blog post that's able to kind of convince them to actually send more money than he should have gotten? Or I don't know, they decide to send to some.
I'm fine with 10K, Edgars.
You're fine with 10K. Exactly. We both agreed. So we want this contract to actually be enforced the way it is. So what this lets you do is basically constrain. You're only using this non-deterministic code to make this one decision, true or false, and that can be quite reliable. But then for sending of the money and where to send the money and all of this stuff is fully deterministic. So it's always going to happen exactly the same way. There's no flexibility for the validators to make any other decision. There's only one possible way to execute given this answer from the non-deterministic block. So the reason is, yes, so that you can isolate it, constrain it, make it as reliable as possible, kind of narrow it down, only use this flexibility, this extra power, this like non-determinism in a very constrained way. And then you can also have this criteria for each one of these blocks. As Christian said, you can have many of these blocks, and each one with different criteria, different tasks, and you can make it quite constrained, and it makes the system a lot more reliable, and you get the best of both worlds, because there are many things that can be, like transferring money. Everything you can do on Ethereum, like those kind of things, should be deterministic. Not you don't need Uniswap that can arbitrarily decide to send you 10 times more or less token. I mean, it might be a fun experiment, but really you don't want that. Whereas sometimes you do need this extra flexibility, this extra power. In that case, you can use it, you can constrain it as much as possible, and you can make it really reliable.
You could build a gen swap and just send out mystery boxes. That would be the
exactly. You could.
Everyone gets a part. Yeah, sky's the limit. Everyone gets a part. No one knows how much. But yeah, that's interesting. So you could say, that's the code. If this happens, that would be the non-deterministic part. Fetch the internet. Find out if whatever, a pope or anyone else in the world died, was born, if a person by this name was born in this city, then, the intelligent contract goes out, fetches the data, and then the deterministic part would be, okay, transfer this exact amount of money or whatever you want to transfer, like ETH, whatever, to Christian. That would be the deterministic code. You actually don't want to allow non-determinism everywhere, because it would just give you probably too many attack vectors, I guess.
Yes, it's attack vectors. It's just extra risk, and it's also performance. You don't want when I click a button, just to jump out in more general terms. When I click a button on a screen, I just want what the same thing happen every time exactly and instantly. I don't want this application to then go and ask ChatGPT, hey, the user clicked the mute button. What should we do? Should we mute it, or should we? I don't know, remove Christian from the call, because then anything could, 1% of the time something weird could happen. GenLayer lets you stack many of these validators so that they actually go from this 99% accurate to 100% accurate and deal with this non-determinism. But there's a cost to doing it this way, and you don't need this for things that need to happen the same way every time, this deterministic action. So you can, it's also, that's the third point, is the cost, of course, because running these transactions, calling to the LLMs, that has a real cost. The cost is dropping rapidly. If you're paying attention at all, it's crazy how much cheaper and faster everything is getting. At the same time, there is, you're still running these on these really big, expensive GPUs, and it takes a lot of electricity compared to running a very simple deterministic instruction. So that's another reason why you would want to make everything that you can deterministic and isolate these non-deterministic parts.
Okay, fun fact in between, Gingo, I love the Zamifolia. I think that's how it's called. Is it correct?
Yes, I never remember what it's actually called, but I love it. It's so easy to keep alive, and it keeps growing like crazy. It's perfect.
That's why we have amazing community members who can just tell us how it's called.
Exactly.
Like we don't even need.
We're all here to learn.
It's the gen plant now. It's the gem plant. It just keeps growing. It just keeps adding intelligence.
The gift that keeps on giving.
Okay. I'm just pulling up another question that we have before the cotillion. In what way does GenLayer's architecture shift the burden of trust from Oracle data sources to validator interpretation of that data? I think it's fitting to what we just explained. You can fetch any data from the internet. Obviously, there's a lot more questions on that. Like, I think we could make a full live stream just about how does data fetching work. And you guys would probably still have enough to talk about. So what do you think about architecture shift from Oracle data sources to validator interpretation of the data?
It gives you more control. With and at the same time, you have to accept some, not exactly limitations, it just works a little bit differently. To set the stage, I think the two kind of oracles that you have right now, the two options basically you have right now, one type of oracle, kind of chain link style, is for data feeds. So price of Ethereum on a centralized exchange, it's a simple number. You can get it. What you can do is also aggregate it across different exchanges, but it's a single type of data point, and they provide these different kind of data feeds. So if the application you're doing, you're building a lending protocol, you need the price of Ethereum, and great, these oracles are doing a great job. Most of the times, you're still going to want to keep actually using these kind of oracles because it almost like it's in this deterministic. It's not exactly deterministic, but it's similar to that. What works like that, you should keep doing it that way. So GenLayer is not going to improve on that specific aspect of it. However, a lot of the questions you would want to ask do not have a simple API, do not have a data feed that can be simply kind of aggregated through an oracle. Who wins the election? You don't have an API that tells you that. You just have some blog posts, news articles on news sites, right? On BBC, on CNN, on Fox News. More than that, you have these articles, but it's not trivial to even find the article programmatically. If you just try to use simple Python to go to the BBC homepage and find the article about the election, that's really difficult to do without using AI. And also, once you have this article, it's again, it doesn't just say president equals Trump. It says, it has a whole news article describing what happened in the election and that this or that entity has decided to call the election, or now it's officially announced, or all this criteria. So it's not the kind of answer, and because this is an answer that only happens once, you're not going to have an oracle in the traditional sense that can actually give you this answer, give it to your application. So the only option so far has been to use human-based oracles like Kleros, like Uma. So these use the power of human brain, of humans basically, to be able to interpret these kind of non-deterministic data sources. A human can look at an article and tell, does this article say that Trump won? Yeah, okay. And make that decision. But the downside of that is the cost and the speed. So it takes multiple days, thousands of dollars to resolve a query like that. GenLayer kind of gets you in the middle of that. So you can have these arbitrary one-off questions. Is it flooding in Lisbon? Is it, is there an earthquake in Japan? Has the flight been canceled? You don't need to go off and build a whole new oracle system just for each one of your questions, which is a huge upfront cost. That's why you only have these oracles for things that are repeatable, that are simple. You can ask any question. You need a little bit of work to fit it into the intelligent contract to make it really reliable. But you can ask basically any question that has an answer on the internet, and then the optimistic democracy, the system can extract the answer in a reliable fashion through cross-checking it across many validators if needed to really check that the answer they've extracted is correct, and go from the limitation that these systems might be 99% accurate to really 100% accurate, so that you can actually make these decisions based on this. And it also gets smarter and smarter as the AI gets smarter. That's the benefit of the GenLayer system. You're not locked into one specific AI model. If tomorrow GPT-5 drops, right, our validators can start to use it, and all of a sudden all the contracts become smarter and more reliable.
More intelligence, basically. You add some more intelligence at the base layer, you increase the intelligence of the whole network.
Yes.
I mean, I myself have some questions, but I think there's enough of them here in the chat. Actually, the Cotillion says it's a Zamioculcas. So, Edgars, you can look it up.
Well, I think we need to do some optimistic democracy then, because now I'm confused. Now I don't know what it is.
Send the screenshots to many validators and they will decide.
Yes. Well, I can mention, by the way, going into kind of a roadmap, a little sneak peek, is that something we're looking at, by the way, is right now the GenLayer system works with text queries, so text prompts. So you can take a text article, extract the text answer from it. However, you've probably seen that most of your AI chat applications also support images or audio or different types of multimodality. The nice thing about our architecture or design of our consensus mechanism, and we're looking to add kind of the prototype of this in the near future, is that you can also have vision-based tasks or multimedia-based tasks. For example, if we had a contract, I don't know, there was some betting contract about what plant is going to be in my room, then the validators, once we implement this functionality and there's enough large language models out there that support this in a reliable way and can make a good decision about it, then they could all look at this picture, and see one of them is going to propose, well, now I've forgotten even both of the names, but, one of them is going to propose some name, the other ones are going to see if they agree or not and resolve this. But more seriously, you could use it for things like, imagine insurance. So take satellite imagery and decide, is this house burned down or destroyed by a hurricane, and pay out the insurance contract the same day instead of like a few months later when you really need it, or is the ship where it needs to be if it's some shipping contract, or anything that you could see from aerial data, for example, or anything else that uses vision or audio, video in the future. Right now, these models are getting to be usable on that front. We're looking to have like a prototype so that you can start playing around with this functionality.
And then you basically get it within, you have a contract, decentralized insurance, your flight got delayed, you get your money within a few minutes instead of waiting for, if you compare it to centralized solutions, I recently got a refund from Ryanair after 4.5 months, right? 4.5 months. I even forgot about the money. Like, that's how long it is. It's decentralized, like, we even have a partner who's doing that, and I think that they've been oversubscribed lately, which is a great sign. Maybe we can. I'm just aware of time, so I would like you guys to answer the last 2 or 3 questions that we have. Beirov, also one very active contributor in our GenLayer community. How does GenLayer address the challenge of versioning and backward compatibility for intelligent contracts when LLMs or external data sources evolve? And what governance processes are in place to manage updates to the protocol's core logic without introducing centralization risks? Very interesting.
Maybe we can take over the first part, and then Edgars can take over.
Go for it.
Actually, for developers, the way that they interact with LLMs is through the interface of the SDK library that we provide. So that it's on our hands to maintain compatibility. It should always be retrocompatible for new versions. We will be adding more and more features on top of them, of course. So and then it's on our execution environment and in the node itself where we make the actual calls to the LLM providers and models. So it's nowadays it's very stable, like the compatibility between all the providers. But as it evolves, it's just about adding more modules and ways to call these different providers from the node software.
Yes, to add to that, the way you can think about it, again, by this analogy to a traditional paper contract, which is you don't write the paper contract kind of hyper optimized for Judge Gary, and trying to write the contract that specifically this judge is going to resolve the way you want. You just write down the criteria that you want as precisely as possible, and then in the end you don't know for sure until you actually take it in front of the judge. It depends. You don't know which judge you're going to get, and you don't know which decision you're going to make. But that's what lawyers are trying to do. They're trying to get the instructions as precise as possible to constrain what the decision should be in the end. Similarly, here is how you should think about writing the prompts or the natural language instructions, which is that you don't hyper optimize it for GPT 4.0.0.1.1.1.6.3, right? Or some specific version that you tested with this specific model that it works like that. Instead, you write it for like an idealized AI-based judge. So again, you just try to be as precise as possible in your instructions, as clear. Of course, you test it with the current level of technology to make sure that it works across many different validators, but you don't know which AI is going to be resolving it. Multiple ones, in fact, are going to be doing it. You don't know which ones exactly. In the future, they're going to be even smarter. So what you have to do is you just write the criteria as clear and simple as possible, and then leave it to the network to resolve this. So it's almost, there's this term imperative. It's you write what you want to happen, you don't specify how it's going to happen, and the system takes care to ensure that this happens.
I mean, Shrieks is saying those who were affected by the LA wildfires would have loved to consult GenLayer. Yeah, like if you had an insurance policy, intelligent contract, definitely. Like last year, I just thought about this. I have a friend in Sri Lanka. They had bad floods, roof, half of the house destroyed. And then he had to ask people from foreign countries, to PayPal him money. But what he could have done is, if you have the insurance policy, you don't even need the bank account. You have, whatever ETH, any other token later on, and you can just, claim the insurance, and you'll receive your money after a news website, whatever, has confirmed that this flood has taken place in this region.
So right now you have two types of insurance available. The traditional type of insurance that most people are familiar with, for example, for your car, is that if there's an accident, then you kind of submit all kinds of evidence. Maybe if it's a house, then of course the inspector is going to come to your house and kind of look, okay, here's the damage or no damage, or this is your own fault or anything like that. But let's say they're honest and it works the way it's intended. It's just going to take like multiple months for you to get the payout. Then in more recent times, you have this innovation of parametric insurance. But the problem with parametric insurance, it's really fast. That's the good thing about it. But it's been relying on quite simple triggers, as they are called. So instead of looking at whether your house is actually destroyed, typical parametric insurance contract is going to look, did the wind speeds in this area reach 160 miles per hour? And if it was 159 miles per hour, well, too bad, your house might still be destroyed, but it didn't reach the trigger. So the upside is speed, but the resolution of the decision is quite limited. Well, in GenLayer, you can have best of both worlds. So you can have criteria that's actually more relevant to you. You don't care what the wind speed was, you care whether your house was destroyed. So you can, as Tony says, look at news articles, or look at satellite imagery, or some drone imagery, or submit evidence in the form of images or videos. It's going to get more and more powerful, so more advanced ways to do it. But basically, you get the speed of AI for this kind of decision making. It's more one-off custom decisions rather than these very broad, high-level triggers.
Yeah, definitely. Matan is asking why I'm flying Ryanair. I don't know. It was the only airline available for this destination, so I had to. Usually I'm not, but you caught me off guard now. Yes. Okay.
Well, it's cool, so that we can spend more money building GenLayer and make it the best that is possible. We have to make sacrifices.
I actually just did it, Edgar's. Okay, you called me now. I actually just did it so I could tell you in this live stream. That's why I took.
Perfect.
The chances were just too high for them not to mess up. That's why I did it. Okay, guys. I think we went through all of the questions. I'm just monitoring the chat once again. Yes, I know we have the POAP, which I'm going to paste in the chat right now. So be fast. It's first come, first serve. I'm going to pin it in 1 second. Here you go. Time for partners is the secret passkey. You can now mint the POAP. after the 100 are gone, it's over. So be fast.
Please reach out in Discord if you have any other questions that wasn't answered.
Correct. Very correct. If you have any other questions, I think we have to do this live stream again, just more in depth, because we, like what I wrote down, we have covered like 20%, which is the most important part. Like I loved what you guys explained, and I think people loved it here as well. It's just that there's so much more to talk about. Maybe we will have to do weekly product, schedule it in the
72-hour live stream marathon. I could talk about GenLayer, I think, for 72 hours. Let's see.
72 hours. Yeah, you got to prepare very well for 72 hours. At some point, you get tired, right?
It comes and goes in waves. Let's find out, I guess.
Okay, amazing. Well, Christian, we mentioned it. Reach out to us on Discord. Join our Discord. Join our Telegram. We have something for everyone to contribute. Developers. Christian, you have been in touch with a lot of developers in the last few weeks, asking about the intelligent Oracle, how they can build on GenLayer. We're also going to release more information on, how developers can get engaged more, how they're going to be able to get grants, what we're searching for, and so on and so forth. So stay tuned. Join us on Discord. Join us. Follow us on Twitter if you're X. Sorry, if you're still not following us. You can also find the Discord and the Telegram in our X bio. And for those of you, again, who are not on Discord, join us on Discord. We have weekly AMAs. We have content creators contests. Then we have meme contests. There's a lot of things going on. Yeah, I think that's it for now, guys. If you have a last word, and then we would call it a day.
It will forever be Twitter in my heart.
Yes.
I don't get used to say X, either.
Yeah, it's just been too long, like just been too long. Yes. Okay, word of the day, Twitter. Thank you, everyone. See ya. Bye-bye.
Everyone. See you around.
Thanks, everyone.